Okay, we're going to look at a sine wave, a trig graph, and we're going to look at amplitude and vertical shifts in a sine wave. And let's just get started. What if we had something like this? If you were asked to graph g of x equals the sine of x plus 1 between 0 and 360 degrees. Well, I kind of like to think of the basic sine graph, and there it is. 0 and 0, 90 and 1, 180 and 0, 270 and minus 1, and 360 and 0. And you just make a nice wave between those 2 points. Now, if you were asked to graph that, you'd have to label the function. We put a g on it and the turning points. But this one here says that it's gone plus 1. You added 1. Well, all you do is you add 1 to all the values. So everything shifts up 1. And that's all you have to do. You'd have exactly the same wave, except it would get shifted up 1. I've used these little green balls to show the wave here in between 0 and 360 degrees. Instead of 0 and 0, it's 0 and 1. Instead of 90 and 1, it's 90 and 2. So everything gets shifted up 1. Here's a computer that's graphed it. And when you sketch this graph, you have to make sure that you label it G. See, it's not labeled G, or with the function right here. And you have to label that turning point, 90 and 2. 270, it's touching there at 270 and 0. But 360 and 1, make sure you label it. And there's the intercept on this side. Remember, we said between 0 and 360. So there's your new graph. That's what the graph of function of g would look like. Okay, what would happen if you did this? If you had f of x equals 2 sine x, if you had to graph that graph? Well, if you put a 2 in front, it affects something called the amplitude of the wave. And all it does to the wave is it makes it twice as tall. Now, if we look at a table, if we go to the tables 0 and 0, 90 and 1, all we do is take the y values and multiply them by 2. Instead of 2 times 0, still it's 0, but 2 times 1 gets you to 2. 2 times 0 is just 0, but 2 times minus 1 gets you to minus 2. Well, I use these little green balls to show them the next wave. The sine of y equals 2 sine x, it's just twice as tall as this y equals sine x graph. Here's a computer that's graphed it really nicely. You can see that it goes up to 90 and 2, still goes through 0 and 0. It hits 180 and 0, but it goes to 270 and minus 2. So the height of the wave, the distance from the middle of the wave to the top, has doubled. The amplitude has doubled. That's what happens when you put a number in front of a trig function. It makes the wave that much bigger, or smaller if you put a fraction there. Okay, well, that's that. I hope it, I hope it helps.